Okay. So as you can see, we have rays. What does it look like an angle is made up of? Two what? Rays. If you look here, there's ray BA and ray BC, correct? Now, how you name it as you draw it. If I started at A, then went to B, and then went to C, would I draw the angle I'm trying to talk about? Yes. What's another way you could name it as you would draw it? Angle C, and then what? B, and then A. The thing in the middle, you always have is the vertex. The vertex. That's the vertex of the angle. It's where the angle changes direction, isn't it? Basically, goes to here, and then what? Changes. And creates the angle. What do you think this is called? The interior or the exterior? This is the interior. This is the what? And when you're on there, you're on. When you're on the sides, you're on. These are the sides of the... This angle is made up of side AB and side what? BC. All of that stuff you should have done before. Are we okay with that? The biggest thing I want you to understand is the ways to name it, because that's where people have problems. Another way to name an angle is to say, if there is a number in there, and I wrote a number in there, that's angle 1. However, this method up here is the only foolproof way to name every angle. Sometimes you can name using just the vertex. Now, I can call this angle what? B. Sometimes you can do that. And as I've told you before, it's just a matter of communication. For this example here. Here, when I said angle B, did you know which angle I was talking about? So here, yes. However, here, would you know which angle I was talking about if I said angle B? No. So in this case, you could use what? Angle B, because it's the only angle that has that vertex, right? Here, though, can you use angle B? Because how many angles have that vertex? Actually, 3. In this case, is there a way to name every single angle here by using the numbers? I can name this angle. I can name this angle. But what about this angle here? You can't write a 3 right here. That would be very confusing to write a 3 inside the line, right? It'd be tough to know what you were talking about. The only foolproof way is to say that this is angle ABC, this is angle CBD, and what's the bigger angle? Angle ABD. Okay? Are we okay with naming angles? Measuring angles. You measure them with a protractor. What you do on this particular protractor, which I have some for you to borrow if you don't have a protractor, if you need it but give it back to me. See how I put the vertex right at that point right there? I also need to line this up with this line right here, the 0. So you measure angles along a circle. See, I'm lined up here and I'm lined up here, aren't I? Well, obviously that's not a 140-degree angle. This is 0, right? What is the measure of this angle? Huh? 40 degrees. And here's how you would write this statement. The measure of angle A is equal to 40 degrees. Did I write out the word measure? What did I write? Lem. That's another thing, part of the language. Like I said, mathematicians are lazy. We don't want to write the word out measure. We're just going to write M in front of the angle sign every time. So I've written one word with one letter and one word with a symbol, right? The measure of angle A is equal to 140 degrees. And that's the important thing, though. You can't say M weird thing A equals 40. If you keep saying that to yourself, you're gonna be confused, aren't you? You need to talk the language. Measure of angle A equals 40 degrees. Draw another angle over here. What does it look like I did? How do you think this angle relates to that one? Here's the thing to remember. Remember that I measure angles along a circle here, correct? Even though my sides I drew shorter here, what does it look like this is? It looks like it's the same distance apart there, isn't it? Now, I don't know that for sure. But if I was to write this statement out, angle A is, what does that mean? Congruent to angle B. What do you think I'm saying? They're the same shape and size. So if the measure of this one is 40 degrees, what's the measure of this one? Now, here's another thing you'll do. If you see an arc like this, and then they draw that right there, you know what they're saying? That arc is saying they are congruent. Okay, that's what that picture means. So what's the measure of angle B? Can you guys tell me that? There you go. Any questions? Okay, throwing a lot out at you in this section. Classify angles by their measure. Ugh. You guys know the three types of angles I just drew? What does this mean when you see that box?
It's a 90 degree
It
angle.
means it's a right angle. It means it's 90 degrees. What is this one called?
Acute.
Acute angle. It means it's less than what?
90.
And this is what?
Obtuse.
Angle, which means it's
Greater than 90.
Now here's the main thing. You can't just go by how it looks, but you can get an idea of what I might be talking about or by it looks, by what it looks like, okay? You do have to be told this, but what does it look like I tried to do there? Well, yeah, I did write an obtuse and into acutes, no doubt. Anybody else? He's right, but not what I'm trying to lead you to. He is correct, though. I mean, just look at those two. I drew this big one first, didn't I? If you guys were watching, I drew the big one first. You tell I kind of measured it? I measured it, and this angle right here was 100 degrees. So I first measured the angle ABD to be, isn't that ABD?
Yes.
To be 100 degrees. Did you notice I made another dot? Try to measure the next one out. Did you guys notice what I measured it to be? What does it look like I measured it to be? And you're right. I measured that one to be 50 degrees. What does that mean this one right here is? So the measure of angle DBC is equal to 50 degrees, and the measure of angle ABC is equal to 50 degrees. What did, see if you guys can talk the language, BC do to angle ABD? Read it as I'm saying it. What did, how should you read that to yourself? Ray BC do to what? Angle ABD.
Make it 100 degree.
Yes and no.
Cut it in half.
What would you say?
Cut it in half.
Did it not cut it in half? Think about it. Before I drew this, right? And he's right because he was thinking from smaller to bigger. It kind of made it 100. I see what you're saying there. You're not wrong. But didn't, before I had this, it was just a 100-degree angle, correct? Would everyone agree? Then I drew that, And what did it do to the big angle? It cut it in. BC is called a angle. It's a word you're going to hear a lot here. Bisector. Bisect something. Bi means what? Two. Bisect it means to cut it exactly in half. Not just to cut it into two parts, but to cut it exactly in half. So when they say something is angle bisector, you know it's created these two congruent what? Angles. And you won't see the book draw the arrows with the angles like that. It's just something I do to try to help demonstrate what each of them are. Okay, get out your, let's go turn to page 7. Okay, looks like we're referring to this picture, aren't we? Well, name the vertex of each angle. Angle 4. What's the vertex of angle 4? Vertexes are points. So how should you write that answer? As a point. Just a capital letter. People usually know the answer to all of these, but you know what they have problems doing? Can anybody guess? They're just writing the answer in the correct language. Right? This is okay. What is number 2? What's the vertex angle 1? What's the vertex angle 2? Huh? What's the vertex angle 5? Wow, that was hard. Name the sides of each angle. Now this is where people have problems. The sides can be segments or rays. You can write it either way. I like to write them as segments myself. Angle 4. What's one of the sides of the angle? This right here, this thing right here, right? But I have to be able to write it. How could I write it? It's a segment, isn't it? Starts at T and goes to, so that's one of the sides, isn't it? I need the other side though. What's the other part? Segment TS. You can't just write TS, because if you just write TS, you mean what? The distance from T to S. And you can write it as a ray if you want to too. But either way is right, is correct. Number 7. Why is that the easiest one here? I don't even need the picture. You know why I don't need the picture for number 7? S to T is a what? Side, isn't it? T to V is what? Another side. But you can look up here and it's still correct, isn't it? S to T, T to V, right? Number 5, what are the sides of angle 5? This is angle 5, right? When you draw the angle, you draw the two sides. This is a side I just drew. What is it?
Segment TS.
Or ST, either or, yeah. And then when you draw this side, it's segment what? TW. Angle 1. Give me a side.
Segment WC.
And Any questions there? It's okay to have questions. All right, another name for each then angle. Angle 3. What's another name for angle 3? Huh? Why can you not say angle T? Because there's other angles drawn there, correct? That would be confusing. So, that would be angle WTV, would it not? Or you could say angle what? VTW? So right now it's almost like a vocabulary, it's almost like an English problem where I'm having you put the definition of this word in a sentence. You know what I mean? You're kind of applying what each is here and being able to do it yourself. Angle 4, what's another name for angle 4? UTS, as I draw it, or someone else, another name for it. STU, angle STU. Now, what about angle 2 down here? Give me another name. Huh? Why should I probably not say angle V? Because there are other angles here. Now they don't have labels, but there are other angles, aren't there? None of these here should you use just the vertex. Okay? WTS. What's another name for that? How about angle 5? Or angle STW? Questions there? All right. Classify each angle as right, acute, or obtuse. Then use a protractor to measure the angle to the nearest degree. First of all, let's just classify these. Angle NMP. (14) OMN. O to M to N. That's a cute angle. This is a joke. You're supposed to laugh. Very much better. QMN. And QMO. I have a problem with this one. I am going to say it's obtuse, but I'd have a question mark as well, because it could be what? If they don't write it on there, you can't assume it. But then again, it's so close, but it does look like, if anything, it's more than 90, so this would be a good educated guess. However, when you measure it, let's see what happens. Zoom in here a little closer. It's really, well, that's not quite 90, is it? Because look how it's going. It's about 100, isn't it? See how it's going to go to 100, not 90. I'd say it's 100 degrees. All right, so you have time to work. I hope you guys can measure angles. If not, we'll come back to it, and I'll do that. I'll help you with some of those tomorrow, but let's get to this one. In the figure at the right, BA and BC are opposite rays. You know what the measure of opposite rays are always going to be? Something you'll use over and over and over and over again. You know what the measure of any straight line is? You know what the measure of that angle is? 180 degrees. Something you use over and over and over again. Now, our opposite rays, BD bisects EBC. So BD bisects EBC. So I could mark, see, this is what's good about using these marks. It tells you this is congruent to what? So now, when I come over here and I label things, I know that this is the same measure as that. EBD, what is the measure of it? 4x plus 16. And see how I wrote this in here? Sometimes you'll see them put parentheses and degrees, but I'm representing the measure of this angle when I draw it inside the angle. What is the measure of DBC?
6x plus 4.
Fine. They want us to find the measure of angle EBD. I'm going to zoom in here a little bit. Really, everything that problem told me is right here, is it not? And by the way, writing the problems, drawing the figures, show all steps of work would be writing that equal question mark. That's writing the problem. Now, showing all steps in work will be what we're about to do. 99% of the time, when it looks like what? Algebra, when you have X's all steps, what do you need to probably create? A valid equation. What do I know about this measure and this measure? They're the same. What does this represent? The measure of that angle. What does this represent? The measure of that angle. So what could I say about these two things? If they're what? Equal, aren't they? Because they said that this bisects, so it cuts it in half, so this is congruent to that. So basically the measure of angle, I'll write this down in symbol form, EBD is equal to the measure of angle what? DBC? Well, what is represented by the measure of angle EBD? So 4x plus 16 is equal to, what is represented by the measure of angle DBC? 6x plus 4. So they're equal, aren't they? Because they told me this bisects it. So that told me these were congruent. At this point, it's just what? Algebra. I'm going to subtract 4x. I got 16 is equal to what? 2x plus 4. Subtract 4. 2x is equal to 12. Divide by 2. X is equal to. What would happen if you stopped right here? I guarantee you one of the answers on a multiple choice test will be 6. And you're not wrong. X is 6. But what did the question ask for?
What's the measure of EBD?
And EBD is what? 4 times whatever what? X is plus 16. So make this 4 times 6 plus 16, so that's 24 plus 16, 30, 40 degrees, right? So there's the answer. All right. What does Mr. Google Calendar say our assignment is today? You might need to pay attention to it rather closely, huh? Well, I'm going to pull it up on my Google Calendar. You click on it and you get details. And what does it say? 1 through 10, 12 through 29, what? And then 37 through 43. On all of these, write problems, draw figures, show all steps, and work. We need to practice this a lot. This is a very, very, very important section. So I didn't want to, of course, sign 43 problems. I know it's about 35 problems. Somewhere around there, 32, 33, that is a lot. But, like I said, this is a very, very, very important section. You guys see how I was sitting here in Google Classroom, went to geometry, clicked. Or not Google Classroom, Google Calendar. Because Google Classroom, you won't see this. And it's a fault with Google Classroom. So I'm saying we stick with Google Calendar. Any questions there? Monday,
Do we need a protractor?
I think. Yes, Monday.